Well, thank you all for joining today. This is the Southern California Sector-Specific Drought Outlook. I'm Andy Hoyle from the NOAA Physical Sciences Laboratory, and just representing a team of individuals from the California Department of Water Resources, the National Integrated Drought Information System, and my institution, the NOAA Physical Sciences Laboratory. So our effort here is to modernize drought early warning and taking a page out of the playbook of tried and true methods that are used internationally. The World Meteorological Organization has done a lot of work on this and assessing drought and providing early warning. And other organizations internationally have done so as well. The Famine Early Warning Systems Network is one such example, and that's where we're taking a lot of these principles from. So our vision here is drought resilience for the nation's economic sectors. And our mission is to inform early warning decision-making based on co-developed sector-specific and evidence-based drought intelligence. The sector-specific aspect is really where we're drilling down on because we feel we can affect decision-making based on the information that we have and really tailoring the information to those sectors. So we're doing this monthly, and we are providing drought scenarios based on the integrated and tailored monitoring and forecasting information we have. So modernizing drought early warning here, the three sectors that we're focusing on are agriculture, water utilities, and public health sectors in Southern California. So Southern California is the 9 counties, essentially south of San Luis Obispo and San Bernardino County, sans Kern County, that you can see in the middle of the map like so. We do this in the context of the Southwest United States because the water resources within Southern California is really tied to what is going on in the Southwest United States. Now, our effort here, we've been doing this for several months now, since 2024, late in that calendar year. And we are now at the 22nd of May of 2025, and we'll continue to do this throughout the summer. And we're doing so here focusing on sectors and the effect of extreme heat and how that affects drought and the sectors and the downstream cascading effects of heat and drought. So you'll notice that as a big focus of our presentation here today. When it comes to these sector-specific perspectives, we're always interested in making our process better. And we throw out to you, our audience, what questions do you have about drought and what are you considering? What topics are you considering regarding drought and its cascading effects? We would love to hear from you via email. We'd love to hear from you during this presentation here, whether it's at a time to speak up or within the chat box as well. So the sector-specific drought briefing will proceed as follows. First, we'll provide a global perspective where we'll outline global conditions that are relevant to the Southern California sectors, and principally focusing on aspects of the Earth system that vary slowly and behave in a way that affect other regions of the globe, including Southern California. The next is providing a regional perspective, where we'll outline Southwest U.S. drought conditions that are relevant to Southern California sectors, and focusing on the monitoring information that we have, in addition to the forecast information that is important to the Southwest and Southern California. And then finally getting into the sector-specific drought outlook, which focuses on public health, agriculture, and water utilities, and the reason and the evidence basis behind the sector-specific perspectives in the scenarios that we will provide. So in interpreting the sector-specific scenarios, we assign confidence levels to the scenarios that we're going to provide here. There's high confidence, medium confidence, and low confidence. As you can imagine, high confidence is we're highly confident in something because we have close agreement among several robust sources of evidence. Medium confidence, we have modest agreement among several robust sources of evidence. And then finally, if we have very low confidence in a scenario, we say so, and what we find there is little agreement among several sources of evidence. So the global perspective is the first part of the presentation, but I want to take a pause here to allow folks to reflect and perhaps ask any questions that they may have. All right, so hearing none, let's move on here to the global perspective. You may have heard of the El Nino Southern Oscillation, and you may have heard of it a lot. It's very important, obviously, to United States weather and climate. And it's composed of El Nino, La Nina, and neutral phases, and it's related to weather anomalies that are used to predict conditions over California months to seasons in the future. The reason why this is the case is because the El Nino Southern Oscillation phenomena varies pretty slowly, doesn't change quickly. And because it doesn't change quickly and it has some pretty big impacts globally, what we tend to see there is a level of predictability, being able to leverage that information into understanding what drought outcomes we can see over the Southwest United States. The second main point here is that a short duration La Nina event recently ended, and neutral El Nino Southern Oscillation is currently the current ENSO state, and it's forecast to be so until the end of 2025. Now, when we look at the El Nino Southern Oscillation, we can look at many different measures or indices, as we call them. This one right here happens to be what we call the Nino 3.4 index, and it's very simply the average sea surface temperature anomalies over the central tropical Pacific Ocean. And as you can see, it varies on the order of 6 months to a year and perhaps even 2 years out. And what we've seen most recently in the last few years, going back all the way to 2023, was that pretty strong El Nino event during that late in that summer, that fall, and into that winter. Now, since then, the El Nino Southern Oscillation transitioned to neutral and then finally to a La Nina state late last year and into early this year. It was a very short La Nina event, and as you can see here, just falling below the threshold of a La Nina. Now, in recent months, what we've seen is that this index, the Nino 3.4 index, has trended toward no departure from average, meaning that the El Nino Southern Oscillation has been neutral. Now, as we look forward, we have several different measures and metrics of El Nino Southern Oscillation forecasts. This right here is from the NOAA Climate Prediction Center, and what it does is it aggregates all types of information, forecast information, and provides an expert assessment on what the most likely state of the El Nino Southern Oscillation is for several 3-month periods in the future, extending from April, May, June of 2025 through December, January, February of 2026. They assign probabilities for neutral, La Nina, and El Nino. And what you find here is that the most likely outcome through the end of the year is that of a neutral El Nino Southern Oscillation. So at least according to this forecast at this moment, there is not an indication that there will be an El Nino or La Nina event. If anything, a La Nina event is favored compared to El Nino, but we'll need to keep monitoring this as we go through the summer because these forecasts can change because this time of year, the predictability of the El Nino Southern Oscillation can be quite low. Now, this map right here is sea surface temperature anomalies across the global oceans. And I really show this here to just illustrate that while a La Nina ended, there's some aspects of the global oceans through the sea surface temperature anomalies that continue to behave like we see during La Nina. And most notably there is the Western Pacific Ocean's very, very warm. Those are conditions that you tend to see only during a La Nina event, or in a modern world, we tend to see these conditions pretty semi-permanently. At least that's been the case over the last several decades. Our climate, the conditions across the globe in terms of the weather, they're actually behaved in such a way that is more La Nina-like than El Nino-like, owing to the behavior of oceans like the Western Pacific. So while we don't have a La Nina event per se, we have conditions that resemble them, and those are likely to produce impacts through the summer and until later this year, and something that folks like myself need to watch out closely for. Now, moving into the regional perspective, and once I finish the regional perspective, I'll open the floor for questions and comments if anybody has them. Now, key takeaways for the current situation and the current drought is that drought continues across Southern California and the Southwest United States. This has been a feature that we've seen since last summer and has actually intensified quite strongly throughout the autumn and winter and into the springtime of this year. An important point here is that from the 1st of October of 2024 to the 12th of May of 2025, this was actually the 4th driest and 10th warmest such period in Southern California since 1951. So compound drought, compound heat over that period spanning October to May. And then finally, in the recent weeks, we've seen rapid snow melt. And this has been particularly impressive here, not in a good way, in the sense that we didn't really have a lot of snow water equivalent on the ground. And what we did have is rapidly melting away because of warm temperatures, not only in California, but in the Southwest United States. Now, this maps right here are from the US Drought Monitor. So the U.S. Drought Monitor considers several different types of drought and their impacts. It's an aggregate product meant to be a first order or first blush approximation of drought conditions. And what it indicates is that widespread drought remains in Southern California and the Southwest United States. You can see this here, that south of Santa Barbara County down into Southern California, noting moderate drought all the way to extreme drought the further southeast you go into southeastern California. Now, in the Southwest United States, widespread areas of extreme drought and exceptional drought on the border of Arizona and New Mexico. So again, these features right here have been really persistent over the last number of months. One caveat that we do need to include here is that despite this aggregate perspective from the U.S. Drought Monitor, different facets of drought in different sectors will respond differently to drought, and that will be noted as we move forward in the presentation. On the right is the U.S. Drought Monitor class change. So essentially what it shows is, do we have a degradation of classes, i.e. an intensification of drought, or do we have improvement, i.e. drought being alleviated? Well, over California now, we haven't really seen much of a change in the last several months. And part of that is because of the ending of the wet season, a little bit of precipitation over the last 6 weeks or so. But nonetheless, this situation of moderate, severe, and extreme drought still remains. Now, as I was saying before, that period from the 1st of October to the 12th of May was really exceptional in terms of compound precipitation and temperature extremes. And these series of maps here illustrate this in a spatial sense. On the left is the precipitation percent of average compared to conditions during 1991 to 2020 for this October 1 to May 12 period. And noting that throughout almost the entirety of Southern California, that precipitation was about 50% of average. And in fact, you can look at some areas in here. If I were to change the contour interval, you'd see areas with less than 30% of average rainfall. I didn't want to belabor the point, but I think the point's well taken here that it was very dry during this past wet season. On the right, this is temperatures. These are average maximum daily temperatures over this period. And noting that throughout the majority of Southern California, that conditions were actually quite warm, on the order of 0.5 degree Celsius to 1 degree Celsius, all the way up to about 1.5 degrees. One area to note here is that in areas like Santa Barbara County or Ventura County and into Los Angeles County, that areas here actually saw below average maximum temperatures. Part of the reason here is that we saw a pretty significant marine layer in these areas along the coast, which typically only happens during the spring. If you've ever been to these areas this time of year, we actually had almost like an early onset of spring in which we saw the May gray and the June gloom happen a few months early, and hence those temperatures that we're anomalous seeing right here. Now, in terms of trying to visualize the compound precipitation and temperature extremes, this right here shows the maximum temperature for the 1st of October to the 12th of May period, alongside the precipitation during that time period. And noting here that 2024 to 2025 is in this dot, like so, which was the 4th driest and 10th warmest such period in Southern California. And obviously, I don't have to belabor the point here. Compound heat and drought, not a good situation in this part of the world. Now, going back to what I was saying before about the rapid decline, we have seen a rapid decline in snow water equivalent over the last several weeks, and it's really led to below average conditions widespread across the Southwest United States. So some areas in Utah, Arizona, New Mexico, no longer reporting any more snow water equivalent on the ground. And areas in which we are seeing snow water equivalent on the ground, they're pretty meager. So this is not very good for water resources here, because there's not much snow and water to make their way into rivers and finally reservoirs. Now, and in the forecast relevant to drought, where are we going? Well, the first point here is that above average temperatures are forecast through at least the end of 2025, according to our colleagues at the NOAA Climate Prediction Center, who've been great partners on this project. The second point here is that drought is expected to persist through at least the end of August 2025, according to NOAA CPC. And then finally, soil moisture will remain below drought thresholds through summer of 2025, and most likely remain so through at least December of 2025. Now, beginning here with the seasonal precipitation and temperature outlook. So these were issued on the 15th of May, and they're valid for June to August of 2025. Noting here on the right that above average temperatures are highly likely throughout the southwestern United States, in addition to Southern California as well. On the left, the seasonal precipitation outlook indicates a slight tilt in the odds to above average precipitation over Arizona and really extreme parts of southeastern California. The reasoning behind this is when we tend to see below average soil moisture, as we're seeing right now in these areas related to the North American monsoon, we tend to see a tilt in the odds to above average precipitation, which is being noted here in the forecast. Now, it follows that for the 3-month drought outlook starting on May 15th, so this is valid through August 31st, that we're not seeing any change in the drought class prediction. That is, drought is forecast to persist across Southern California and throughout the entire Southwest United States. So the combination of heat and even despite the fact that a slight tilt in the odds to above average precipitation exists, that drought is predicted to persist throughout that period. Now, as we look to later in the year and getting into the next wet season in the Southwest and Southern California, this is for October, November, December of 2025, and these are forecasts that are issued on May 15th. Noting here that there is a increased likelihood of above average temperatures, but also noting here that there's only a slight tilt in the odds one way or the other in terms of precipitation, and it is to below normal over parts of the Southwest. So this includes Arizona, New Mexico, Utah, and southwestern Colorado. This polygon of below average precipitation does not make its way into Southern California. Now, where we stand right now in terms of soil moisture is that low soil moisture remains across almost the entirety of the Southwest United States. So these warm colors indicate low soil moisture percentiles on the 17th of May of 2025. And you can see that this condition is widespread across the Southwest, in addition to widespread behavior in Southern California as well. This is consistent with the low precipitation and very warm temperatures, anomalously warm temperatures we've seen. These are forecasts from colleagues at the NOAA Climate Prediction Center. And simply what's being shown here is that for May to October of 2025, this is based on conditions on the 10th of May, that low soil moisture percentiles are forecast to persist across Southern California, Southeastern California, and the Southwest United States. So the persistence of drought is prevalent within these forecasts. And it stands to reason because we don't have a precipitation season to really bail us out and change our drought state. Unfortunately, we have temperatures, and warm temperatures can actually degrade our drought situation, and I'll illustrate that in the following slide. Where I want to start here, though, is by showing how soil moisture tends to behave throughout the annual cycle. So on the horizontal axis here, beginning in January and moving through December, what is the 1 meter soil moisture storage, soil water storage in Southern California? So those 9 counties in Southern California. And showing this in a percentile basis here. So basically showing the record low value, the record high value, and all the percentiles in between. Essentially what we see is an increase of soil moisture in the early part of the calendar year during the wet season, a decline in soil moisture as we go through spring, and steady conditions really through the warm season and into later in the year when soil moisture then begins to increase. Now, what happens when we look at drought cases as of the 1st of May? So what this does is it considers soil moisture since 1940, and what we did is we subselected on the 1st of May conditions when we saw soil moisture in the lowest 20th percentile, which is nominally drought. And what we see here is for those conditions since 1940, that these black lines indicate we don't see any improvement in terms of soil moisture. Sans this case in September, in which we actually saw a tropical cyclone come through and really provide a huge dumping of precipitation. These are pretty rare events and also pretty consequential in a negative sort of way. So I don't think we would actually root for any of these things to happen here. One thing I want to draw your attention to is here on the right. What we did is we took conditions since 2000 on May 1st in which we had soil moisture below the 20th percentile. What you will note here is that when we have soil moisture below the 20th percentile on May 1st since 2000, we actually have a decline in soil moisture. This is not really something that's very apparent in the 1940 to 2000 case. What this indicates here is the importance of temperature. Since 2000, it's been quite a bit warmer than conditions prior to that. And as a result, that does have a pretty significant effect on soil moisture as we move from May to June and throughout the summer. So again, we're starting to really highlight the importance of temperature and its effect on the weather conditions, its effect on the environment that will be reflected in the drought scenarios. Now, before we move on to each of the sectors, I think it would be a good time to pause and ask if there are any comments or questions from those in the audience. Okay, well, hearing none, let's move on here to our public health sector. So the public health scenario is as follows. Poor air quality in Southern California is expected during summer 2025 due to smoke from wildfires, and we're very highly confident in that. Anomalous extreme heat, especially in southeastern California, is expected during June to September 2025. We also have high confidence in that as well. So the supporting evidence, which I will present in the following slides, is that there's an elevated risk of significant wildland fire potential in Southern California in the entire western United States, above average temperatures in summer of 2025, and above average number of days exceeding 100 degrees Fahrenheit in summer of 2025. Now, where we begin here is with the air quality index and the location of wildfires this morning, May 22nd of 2025. What you'll note is that in a lot of urban areas, there's moderate air quality. This is actually a little bit different from yesterday and the day before, where there's good air quality. And it's just local weather and atmospheric circulations leading to this situation. One thing that's also noted too is that some areas of wildfires have actually popped up in Southern California. You can see the icons there. I count 4 of them in southeastern California. That's actually new as of this morning, so it looks like there's some wildfires that are popping up. And over the rest of the Southwest United States, like Arizona and New Mexico, this is actually high time for them in terms of wildfires, and you're seeing that here on this map as well. Now, I showed this previously, and what it indicates are soil moisture percentiles on the 17th of May, 2025. And noting here that these warm colors in the Southwest United States indicate low soil moisture. That's bad news because this is a proxy here for vegetation health, which is not doing well in Southern California and the Southwest. And as a result of that, that tends to lead to a situation in which we see a more likely situation of wildfires. So these are from colleagues from the National Interagency Fire Center, where they assign probabilities of above normal, below normal, and normal significant wildland fire potential. When you see reds on this map, it means there's an above normal significant wildland fire potential. And for June 2025 on the left, August 2025 on the right, you can see that throughout the entire Southwest that there's an increase in the significant wildland fire potential. Now, as we move through from June into more of the core of the summer, the Southwest United States really isn't under the gun as they are during the spring and early summer. And that just has to do with their fire season. But what does move in here, what does become more apparent is that California, Nevada, and Northwest United States, those are the areas where summertime wildfires are very prevalent. And not only seeing wildfires in Southern California, but also through the Northwest and just the way the weather behaves. A lot of this poor air quality can make its way across the country and really degrade air quality, not just in Southern California, but throughout the entire Western United States. So this map right here is showing vapor pressure deficit. Vapor pressure deficit is just simply the difference between the amount of water that the air can hold and the amount of water that the air is actually holding. And when there's a big difference between those two, as in the air can hold a lot more water, that's a high vapor pressure deficit. And we have a high vapor pressure deficit that leads to wildfire. And as a result, vapor pressure deficit is really a key indicator of wildfire potential. So these are forecasts of above and below normal probabilities of vapor pressure deficit for June to August of 2025. And you can see here that across almost the entirety of the Southwest United States, that there's an increased likelihood of having above normal vapor pressure deficit That combined with really poor vegetation health across the Southwest and Southern California is going to lead to a situation where wildfires are just going to be more prevalent. On top of this right here, we have above average temperature forecasts, and we noted this earlier on. Also noting here that in the seasonal precipitation outlook related to the monsoon in the Southwest, that there's only a slight tilt in the odds to above average precipitation in Arizona and southeastern California. Now, one analysis here that we feel is useful is by showing the June to September maximum temperature in California. And that's what's shown here on the left. This is maximum temperature from 1951 to 2024. So this is from the National Centers for Environmental Information data set that they put out. So in Southern California, you can see that throughout almost the entirety of the region, that temperatures are on average greater than 30 degrees Celsius. And even in some areas, the further southeast you go, that temperatures on average are greater than 40 degrees Celsius. Now, if we were to subselect cases based on our drought cases that we showed previously, so all drought cases since 1940 and drought cases since 2000, that during a drought since 2000, that average temperatures during the summer have been about a half a degree Celsius, 1 degree Celsius, 1.5 degrees Celsius above the long-term average. So very noteworthy in the sense that warm maximum daily temperatures are the norm during drought cases since 2000. Now, if we want to dive a little bit deeper, what we can do here is to look at the number of days that exceed 38 degrees Celsius. That's nominally 100 degrees Fahrenheit. So on the left, what's being shown here is June to September days exceeding 38 degrees Celsius. And noting here that in extreme southeastern California, that greater than 80 days, so basically 3 out of the entire 4 months see days with greater than 100 degrees Fahrenheit. Now, if we're to subselect based on those drought cases that I showed a few slides ago, and particularly focusing on cases since 2000, noting here that much of southeastern California sees about 15 days or so more than the average in which we have temperatures greater than 38. And trying to put that in the layperson's terms, it's basically 2 more weeks of extreme temperatures in southeastern California. So a pretty noteworthy increase in southeastern California, but not to leave out other areas further to the west within the region, where we're also seeing 3, 8, 6, 9, basically a week's worth of or more of having temperatures at those extreme levels. So drought cases since 2000 really are indicating just a harbinger of things to come for this coming season. So this right here is the public health scenario, just to reiterate it. And I think now is a good time to ask if there are any comments or questions from those in the audience. Okay, well, hearing none, we'll move on here to the agricultural sector. So within here, we made 2 statements for the scenario. The first is that low forage production in Southern California is expected in spring 2025 due to the ongoing agricultural drought. We're highly confident in that. And then finally, anomalous extreme heat in summer of 2025 will hinder the productivity of agricultural workers, particularly in southeastern California, also high confidence. The supporting evidence here is that forage production is behind schedule due to the ongoing agricultural drought. Above average temperatures are forecast in summer of 2025. And then finally, above average number of days exceeding 100 degrees Fahrenheit in summer of 2025 are likely. Now, when it comes to annual rangeland forage production in Southern California, conditions begin to ramp up in March, reach a peak in April, start to decline in May, but still a materially important month, and then go to 0 in June. This follows here both the precipitation and temperature seasonal cycles, where the land surface is moistened by precipitation during the winter. Temperatures increase during the month of March, thereby allowing vegetation to grow. And then by the time June rolls around, precipitation hasn't been observed in quite some time, and also temperatures are quite warm, so agriculture becomes dormant. Now, one important thing to note here, and this is actually tied into and related to temperatures, is the demand of water by the atmosphere from the land surface. This here is from a pretty popular index called the Evaporative Demand Drought Index. And what it measures is the amount of water that the atmosphere is demanding from the land surface from several considerations like temperature, from winds, from solar radiation, and so on. Principally what's happening here in Southern California due to the extreme warm temperatures that we've seen over the last number of months is that evaporative demand because of those temperatures has been very, very high. This really spells doom when you're in a poor situation where you haven't had much precipitation. So you have a limited amount of water at the land surface, and when that water is being constantly demanded by the atmosphere, then it really doesn't lead to a lot for vegetation. Now, forage growth is significantly behind schedule. So for San Luis Obispo County, forage growth is behind schedule, and 3 to 4 inches of precipitation would have been needed to reach average production. Well, obviously, that did not happen. And we fell far below precipitation and thresholds that were needed for forage growth. And then finally, with Imperial County, forage growth is also significantly behind average with meager precipitation this wet season amid large long-term deficits. And those large long-term deficits refer to precipitation deficits that we've seen over the last decade plus. And just highlighting here again that soil moisture is very low based on those soil moisture percentiles. These pictures you've seen previously, but I included in this part of the presentation just because they're relevant. But just highlighting the point here is that during summertime, because of the exceptional temperatures, that we can expect a situation to unfold like we have in many drought seasons since 2000. That is, still seeing a decline in soil moisture during the summer because the exceptional temperatures, those exceptional temperatures will further rob the land surface of whatever little moisture it may have. Also, just highlighting here as well with these temperatures, basically seeing upwards of 2 to 3 more weeks in summer, this coming summer, related to drought, and 2 to 3 more weeks of temperatures exceeding 38 degrees Celsius or 100 degrees Fahrenheit. Now, this right here is once again the agriculture scenario. Are there any comments or questions? We welcome them at this time. Okay, well, hearing none, moving into the final sector, which is water utilities here. And the scenario that we developed here is compared to April of 2025, reservoir storage and groundwater levels are expected to be lower in October of 2025. We're highly confident in that. And also lower in June of 2026, where we have some medium confidence in that. So the supporting evidence here is the rapid decline in snowpack throughout the western United States. We don't have any indication of substantial replenishment of, of water resources due to above average precipitation in the 2025 and 2026 season. And then finally, the Bureau of Reclamation projections over the next 2 water years, which are actually quite dour and depressing. So this right here is from California Water Watch. And what it indicates with these dots filled with colors is reservoir storage as a percent of average. And this is from the 21st of May. Noting here that throughout much of Southern California, reservoirs are somewhere about the average. And these values have actually declined a little bit over the time period that we've been working on this drought pilot, but not significantly so. And we would expect them to decrease a little bit more as we go through summer as demand and use of these reservoirs really ramps up. Now, in terms of groundwater levels, groundwater is pretty mixed. It has been for some time because of really just overuse in the demand, and that groundwater just doesn't really have an opportunity to be replenished even during those seasons where we see those above average precipitation levels. Now, just once again, presenting this slide with the rapid decline in snow water equivalent in the last several weeks. It's led our colleagues at the National Integrated Drought Information System to really stay on top of this and to really disseminate a lot of information regarding this. It's been very drastic, And if you looked at this a few weeks ago, conditions were much better than they are right now, just owing to the extreme warm temperatures in the southwest United States and their effect on melting snow on the ground. And now moving on here to precipitation as we move into the next wet season. On the left right here is October, November to December precipitation, seasonal precipitation outlook from the NOAA Climate Prediction Center. On the right is January, February, March forecast for 2026. Again, these are forecasts from May 15th of this year, so they're very long lead forecasts. But what they are indicating, at least preliminarily, is a slight tilt in the odds to below average precipitation over the Southwest. Now, remember, I don't know, about 20 minutes ago, I was saying, there's aspects of the global oceans that are behaving in a way that are similar to that of La Nina, despite the fact that we don't anticipate having a declared La Nina. This is the effect of that. So those sea surface temperatures that I showed previously that resemble La Nina, they do have an effect that is similar to that of La Nina. We've seen this a lot over the last 2 decades, and once again, we're seeing this here in precipitation outlooks. This is just being shown in terms of the expert interpretation, but if one were to go and look at the forecast models that the expert forecasters use to make this map, those below average precipitation areas do stand out. And not only that, we see below average precipitation in the southeast. So this map right here is actually somewhat reminiscent of a La Nina, and for good reason, because the global oceans in a lot of ways are behaving in that way. This right here will have to be continually monitored. It's something we're going to focus on for quite some time, and to try to extract the maximum amount of predictability we can at these long leads. But this is not an optimistic forecast for the next precipitation season in the next water year. Now, moving on here to water availability forecast. So this is for Lake Mead. Lake Mead is very important for Southern California. And there's a couple different curves that you see on here. One is the black curve, which is showing the historical elevations of Lake Mead in its pool elevation in terms of meters. Now, these different colored curves are showing probable maximum inflows for April 2025, May 2025, and May 2025. What these two Mays differ here, and they differ in the ability of a Lake Powell release. So the May 2025 picture shows a Lake Powell release of 7.48 million acre feet in 25 and 26. And then this May 2025 in red indicates Lake Powell release of 7.48 in water year 2025 and 2026 here. Now, these two features right here, these two curves are not good. Obviously, they don't really, they're not optimistic. They would bring conditions down to a shortage condition, sort of where we were a few years ago. And it's something that needs to be continually monitored here. Obviously, we would like to say that the April 2025 inflow and the Lake Powell release of 7.489 in water year 2026, but that can't be banked on. So this is an entirely likely outcome, and of course, why the Bureau has put it down here. So something to really consider, and this is what the scenario was based on that you find on this slide. So with that, I'll finish up the water utility scenarios. Are there any comments or questions from those in the audience? Okay, well, hearing none, that is the final slide of the presentation. So we thank you all for joining. We'll make these slides available and the recording of the presentation available tomorrow, as well as a written summary of this presentation too. So as always, if you have any questions in the meantime on the material we presented and you'd like to contribute, please let us know. But until next time, thank you.